Imagine you're in your dorm room and you start craving for instant noodles. Now imagine the seasoning packet safely dissolving into your soup, so you never have to throw away that tiny plastic wrapper. That small change captures the big idea, using starch-based bioplastic to tackle plastic waste. Starch from crops like potato, corn, and cassava is made of two glucose-based polymers, amylose and amylopectin, which behave differently when heated in water. When you heat starch in water, the granules swell and burst in a process called gelatinization, turning it into a thick gel, and when it dries, the chains lock together with hydrogen bonds and form a brittle film. To turn that brittle film into something useful, I add glycerol. What's going to happen to that? Glycerol is a small molecule with 3 hydroxyl groups that slips between the starch and keeps them from packing it too tightly. With glycerol and a little bit of acid like vinegar, the dry gel becomes more flexible. Plant-based plastic with thickness, strength, and degradability depend on the recipe and the starch source. This chemistry is already leaving the lab. The world currently relies on huge amounts of fossil-based plastic for single-use items, especially food packaging, which often ends up in landfills or the ocean. In Indonesia, a major plastic polluter but also a major cassava producer, they have begun making cassava-based bags and food packaging that dissolve in hot water or break down more quickly in soil and marine environments. So when you picture that late-night noodle run, the same chemistry that lets a cassava bag dissolve in hot water could one day let your seasoning packet vanish into the broth instead of into the trash. That is planetary problem solving at the molecular scale, teaching something as ordinary as starch to behave like plastic, so society can keep the convenience but not the permanent pollution.